We recently just covered and explained Apple's paper, The Illusion of Thinking, talking about how AI reasons and their flaws to do so. It didn't take long for Anthropic to release this, a comment responding to Apple's paper into what have now turned into a rap diss battle. A short paper titled The Illusion of Thinking, responding to Apple's allegations and explaining what's wrong with this paper. In this video, we're going to dive into that paper, explaining the main highlights and talking about it in more details. Let's jump right in. In this new paper, the authors wanted to show that Apple's findings are more due to design limitations and flaws rather than reasoning failures. They wanted to tackle three main critical issues. First being that the Tower of Hanoi statistically exceeds the token limits of the models, and that their automated evaluation misses the point between reasoning failures and practical constraints. And finally, and most importantly, that the river crossing problem under their constraints is mathematically impossible to solve. What's important to note here is that in the Apple paper, the researchers asked the model to generate every single step, meaning that for the Tower of Hanoi, for example, every time you add a new disk, the number of steps that you need to take can increase by 4. And this keeps growing exponentially, meaning that the model token limits might be challenged by this. In this paper, they noted that one of the things that the Apple researchers didn't really take into consideration is that the models acknowledge their limitations. They said that the models can sometimes refuse to keep going, knowing that the remaining of the answer is too long and repetitive, resorting to solutions like the pattern continues, but since it's getting too long, I will stop here. The researchers said that this is due to model awareness and decision making, which I think is more due to the fact that whenever problems like this exist in books or whatever, the solution usually contains the same output. So, for example, when you're reading about a certain problem and that the solution pattern continues, the book will also do the same thing. But what's important to note here is that some of the model outputs was deemed as wrong because the model did not continue in the prediction, but rather said that they will stop midway. And the author said that this was not taken into consideration when Apple were performing their evaluation. They also said that the way it works is that you have to make sure that every character in the prediction is correct. So, for example, assuming that a problem has 1,000 characters, the way the evaluation works is that they confirm that every character is exactly the same as they would expect. So if you wanted to monitor this as a probability distribution, the way it would be is that the probability of every character being correct. So that would be probability of the first character multiplied by the probability of the second character and so on until the probability of the last character. So if we are taking this into tokens now, this would be the probability multiplied by the other probability all over the tokens. And it will eventually be the p to the power of t, where p is the probability of every character and t is the number of tokens. So they showed that if we were to take the token length as 10,000 and we wanted to check the probability of 0.9999, this will amount to 37% chance or less of this happening, meaning that the chance of getting 0.999 accuracy on all of your characters for 10,000 tokens is less than 37. But when this drops slightly into 0.999, the probability now drops to less than 0.005%. This is because the authors did not keep in mind the slight errors that happen when prediction. Based on what the Anthropic researchers said, is that they are not taking into consideration the ability of the model to acknowledge its errors and keep going nonetheless. The researchers explained that this is a known limitation and failure in models in general that has been published before, and that it needs to take into consideration that the models do not showcase character by character accuracy, but rather they can adapt to their own limitations and errors that happened originally. The other problem that they faced was in the river crossing problem. In Apple's paper, the river crossing problem showed problems in complexity where they had 6 actors as well as a capacity in the boat of 3, which by the original paper is mathematically impossible to solve. There is no mathematical solution for any number of actors greater than 5 if the boat capacity is still 3. Yet the models in Apple's paper were given 0 accuracy even though the solution was, let's say, unsatisfiable to begin with. Finally, looking at the Tower of Hanoi once more, they said that the number of tokens needed to capture the number of steps in the higher complexity problems is actually exceeding the number of tokens the models are able to compute, meaning that the models cannot output a text long enough to capture the number of steps needed for these problems. So basically, they show the calculations for the number of tokens a model can predict, and they showed that there are consistencies between the token limits as well as the model collapse that Apple showed. So the number of steps, or let's say the higher complexities where Apple showed that the model collapsed to zero precision, are actually highly consistent with the number of steps that needed for the model to output tokens, meaning that when the model cannot output any more tokens, the model collapse happens. The researchers also noted that when you change the requirements of the model from asking it to predict every single step to predicting a code that prints the outputs for you, the models were able to write the code successfully in under 5,000 tokens. They said that this means that the problem was not the reasoning, but rather the constraints in generating the tokens themselves. So, what is our takeaway from all of this? Was Apple completely wrong? Not really. See, Apple did a lot of mistakes, and that's fine. But what I think and what the Anthropic paper also says is that we have a problem when we're evaluating AI. You see, a lot of people are saying, oh my God, this model has like this insanely high IQ, or that these models are doing really good on this benchmark. And now we have this paper by Apple that says models cannot reason because of this evaluation. And the problem here isn't the abilities of the model, but rather how we evaluate them. I think that when we are delving deep into these AI models, we should really be focusing more on benchmarks. See, the problem is sometimes when you get a model that is doing insanely good on a benchmark, the question remains, is this benchmark truly hidden from the model, or did the model already learn some information within that benchmark? The question with LRMs and LLMs in general will always be, how do you truly evaluate these in a way that everyone accepts as a right way to evaluate? Because again, everything that the paper now says is true about the evaluation being wrong, but they also constitute a lot of stuff by saying, oh, this is the model's awareness, this is the model being very smart in its decision making, which again, while in this case might be true, but it's not really correct for us to say this is because the model is aware, because the model is not aware. At the end of the day, the model is just predicting patterns. One of the other problems that I see here is that the Anthropic paper says that once we ask the model to generate code, then it works out of the box. And again, models, especially like the models being tested here, have been trained on a lot of code that could or could not, like may or may not have already included the code for the Tower of Hanoi. And code, while does show a set of, let's say, reasoning capabilities, if a human is able to write code that explains in steps how to solve a problem, the human understands conceptually what the problem is. But it's not really the same with models, because when the model is writing code, especially when it starts by writing the first set of the problem, this is now just generating the remainder of the problem with pattern matching rather than conceptually reasoning about what the problem is. Whereas when you look at the problem being like, this is the step that I am, and this is the step that I need to go, and now you have to form the proof of getting there, this entails reasoning and thinking. Now, models could train to generate this, and that will still be a problem for us to say, is it actually reasoning or is it actually doing pattern matching? And this is why we need newer ways to test these models. This is why I think testing the models in a white box manner, where we also look at their neuron activation, might actually be helpful. But someone still needs to think about newer ways to actually look at these models and decide, is this part of the training data or is this just actually thinking? Because I don't think we're there yet. And you might not believe me, you might still be hating on Apple, you might be thinking that this paper is wrong, but this will be up to you to decide. With all of the newer models coming out, with all of the new headlines and noise coming in, you need to start forming your own opinions on this by being educated about it. That being said, let me know what you think down in the comments below, and I'll see you in the next episode.